Hello there. Welcome to the session While We'll Ponder, Bright and Cheery. I am Todd Weller, the Senior Data Systems Architect for Cross IT. Here's a little bit of information about me, both professionally and personally. Unfortunately, that's all the time I have to talk about that, so let's go ahead and move on. As the title of the session today indicates, we are going to be talking about the while function. What that does, for those of you unfamiliar with while, is it allows us to repeat logic within our calculations, returns a result from a combination of initial values and repeated logic that we have access to. What that does with that repeated logic is that now we don't have to use a looping script or a recursive custom function, and because it simplifies things in that way, we're able to make our formulas and scripts a little bit more efficient. As you get ready to use while, you go into the specify calculation dialog box, do the type ahead, and this is what is going to be auto-entered for you. Obviously, you can see there's 4 pieces of information that we need to provide, but it doesn't give you a whole lot of context and everything, and I think it's a little intimidating for those that aren't used to it, and I think that's why not as many people use it as probably could take advantage of it. And so that's why I promote the Wellerized version, which looks like this, thanks to Text Expander that I use on my laptop. I can type a snippet and it appears this way, so I know exactly what pieces of information I need to plug in order to get the result that I want. So what are those pieces of information? Well, we'll start at the top inside the first set of square brackets, and those are the initial variables. You'll notice that that is the declaration of variables that are going to be available within the scope of the function. It takes on the looks and feel of how you would set up a let function. So your variable types are function variables, your script variables, or your global variables. And then, of course, the expression types could be a field value, could be a constant value, or some calculation that uses any number of functions and fields and constants. All right, we're going to skip the condition for right now and move down to that second set of square brackets. And this is where we have the expressions that are going to be evaluated for each iteration of the loop. Again, the variable types are going to be the same, function, script, or global. In my experience, it's always been those function variables or local variables. But again, it depends on what you're trying to calculate. Expressions are going to be the same, where you're going to have calculations, field values, constant values, or some combination thereof. So we'll take a step back here now and look at the exit condition. And what that does is obviously that's a Boolean expression, so you can use whatever Boolean operator to get you the result that you need. It is evaluated first as indicated by its placement here. The function continues looping while this condition is true, which of course means that the function is going to exit with the result when that condition becomes false. All right, and the last thing, of course, is the result. And this is the final result that's going to be returned by the function, which may be just the result, or it could be a nested let or while or any other function that makes sense to get you the result that you need. So with that, let's go ahead and take a look at a little bit of demo. So for this portion of the demo, we're going to be working in this database here that has a number of imaginary people with imaginary names and addresses, just so that we can pull information. And this first use case is where we need to get all of the information from this record into a JSON object, possibly to pass it along to an API or do some type of archiving process, but it starts with getting it all as a JSON object. So as we go in and look at our script workspace, we see we have the script here that's going to do this in what we can see the traditional sense, if you will, where we're just getting a list of the fields on the layout, looking at the total number, and then we set up our looping operation that goes through, gets the field name based on that iteration of the loop, gets the value of that field, and then inserts that value into our JSON object and returns our result. So let's go ahead and run that script. And now if I open up the data viewer, you can see that the script result is the expected JSON object. So everything is looking good. Well, if we were to do that with a while statement, you can see that my script goes from however many lines to just a single script step where I'm setting the variable. So let's go ahead and run that. You can see the result here in the data viewer. Go ahead and drill into that, and you can see that it certainly looks identical to the result that we got with our looping script. All right, so what does that look like? So Just to make it a little bit easier, I went ahead and pulled the calculation out and just pasted it into a text editor so it's a little bit easier to see. And you can see here that, again, we're initializing our variables, still getting our list of field names, the total field count. Obviously that then index less than field count becomes our condition. And then again, for the repeated logic section here, we're incrementing the index, getting the field name, getting the value of that field, inserting it into the JSON object, and then our last thing is just for readability's sake, I'm going ahead and putting it into the format elements as part of the result. So pretty straightforward there. One thing that you'll want to notice is that I declare the index as 0 here, and then I begin incrementing it here inside that repeated logic. And where that becomes important is that as you look here, going back to the original looping script, is that I can just go ahead and set my $index variable equal to $index plus 1 because it knows that it's starting out as 0, so I can just begin incrementing it so that first time it sets the value to 1 that I want. Well, when you're using the while function, if I were to do this without having this, it would actually generate an error because it doesn't know what index is. So that's where this initialize variable section becomes very important. So certainly keep that in mind. All right, so that's one possible use case. Now the second example that we're going to look at is one of the first use cases that I thought of when while was first announced as being part of FileMaker 18, probably the same one that many of you thought of, and that is a replacement for recursive custom functions. So before we get into the example, let me just go ahead and change our found set so that we're just looking at all of the people that live in the state of Pennsylvania. And so what the custom function is here, as you can see, is it just returns a return separate list of values from the found set, where you feed it the field name that you want and the starting position. And this was one that was found on Brian Dunning's site that was originally written by Eilert Sunt. And all it does is it uses the getNthRecord function, again using the field name and the start position. And if the start position is less than the total found count, it then calls itself. That's where we get this idea of a recursive function. So everything looks good there. We'll get back over to our script editor. I'll go ahead and run that script. Now we get back into our data viewer, and you can see that we've got a list of custom cities in our database that are people in the state of Pennsylvania. So everything looks good there. So again, this script here, as you can see, is not very complex, but again, with the while function, I'm able to take care of all of that in just a single set variable step. And so what does that calculation look like? Well, let's go ahead and pull that over here. You can see here we're initializing, setting our index, getting our found count of records, setting the city list to empty so that we can begin adding values to it. Obviously our exit condition, as long as the index is less than our found count, we're going to continue looping. And then here, again, just incrementing our index, again, still using getNthRecord, spelling out what city it's going to be, and then adding it to the list, and then using our unique values here in the result to get the final result. So if I go ahead and run this script now, here we've got our custom cities, and it looks like it's pretty much the same. So everything is working as expected. All right, so let's go ahead and we're going to switch context here. Now we're going to switch over to a system that's just looking at orders that have been placed. One of the typical things that you would be doing with this system is that once the order is placed, you would be sending a packing slip or possibly, printing an invoice that could be sent out as a PDF. So all of that seems to be working. But there may be a case where you would want to send just an email without any attachment that is an order confirmation that also lists that information. And so that's what we have here, as we've got a script set up that's going to go ahead and do that. Now typically when I would work on this problem before the while function, is that you would script it so that it goes from the context of the order to the line items, collect information all about the line items, and then come back to the order to get that information before it fills in the final text. Well, with the help of the while function, we don't need to do any of that. So this here is what the final result looks like. I'll just go ahead and click the button, and you can see here it's taking And it looks exactly as we would expect it to look, where we've got, some body of a message, and then we've got that line item information. So how do we build that? Well, let's get back and take a quick look here in the script editor. You can see it's a fairly straightforward script where we're just making sure we're going to the layout. Again, our drafting of the email message is a single step because of what we're able to accomplish with the while function. And then we just go ahead and load that into a global and open up a card window so we can see it rather than send it to the email client. All right, so let's go ahead and look at the calculation itself here again in a text editor. So again, we're declaring some things, getting the the number of related items to that order. Obviously, it makes sense that our exit condition would be until we reach the last of the items. Again, we're relying on get nth record to collect pieces of information that we want here. Just going to go ahead and putting that into a list, substituting out the return characters with the tab character, and then adding it to our list of items. And this here is where we start to go ahead and nest some things. So we've got our while function, but now we have a let that's nested inside of it. So when it comes back for the order information, we can get the first name, we can build the address in the format that we want. And then the last step down here is to just come to the substitute function using the email template that's been loaded into a global variable for me. And then we just replace those placeholder tags that I've already set up to then generate the result. As you saw with that last example, obviously things are getting a little bit more complex, so we need to figure out a way to troubleshoot our function when we have problems and we're not getting the results that we expected. Unfortunately, troubleshooting a while statement is not nearly as easy as troubleshooting a looping script. Because we're not able to fire up script debugger and then just step through each of the parts of the loop because it's all happening in a single calculation. But there are a few things that we're able to do, and these are the ones that have helped me. First is you can still make use of the data viewer. One of the things that I often do is I uncheck the automatically evaluate option just so that it's not trying to constantly recalculate while I'm making adjustments to my formula. And then once I know that I've got the calculation correct inside the data viewer, then I can move it back into my script step calculation or field calculation or wherever that calculation is eventually going to end up. The other thing that you can do too is to change the exit condition. Instead of having it go through the entire iteration, you can set it up so it's going to exit after that first or maybe just the second repetition of the logic, so you can kind of see what's happening there to make sure that it's starting to build correctly. Because you can exit, if it starts out as false, you can even set it up that way. If there's any question as to whether your variables are initializing properly, you can have it exit immediately by setting the exit condition that way. And the last tip that I have to offer is you can use script variables instead of function variables. And what that does is that's going to provide visibility of those intermediate values instead of just being able to see the final result. And this is where you kind of use it in conjunction with, you change the exit condition, but then you also are stepping through your script with the script debugger so that it pauses so you can see the value of those variables. So let's go ahead and get back in and look at the troubleshooting of the example that we just looked at. I'm going to go ahead and duplicate the script here, and I've got one that's set up for debugging purposes. Just so that I don't mess up the one that's working completely. And this is what that function looks like, where you can see I've made one of the variables that's actually returning those line items into a script variable, and also adjusted my index so that it exits after the first time. So let's go ahead and we will run that. We'll get our data viewer back open again, and then we'll make sure that we run that. See here, I've got none of those script variables are declared yet, but as I step through, now I have both the email message because that completes, but I was able to go ahead and capture that intermediate value, and this certainly looks like what I would expect it, where I'm getting quantity, a part number, a description, price, and the extended price. So everything is looking good there. So what that allows me to do then is I can come back into the script, and we'll just go ahead and, again, just increment it to slowly build back up. That, go ahead and run debugger again, step through, and we come back to the order items, and it's added the second line as expected, so things are looking very good. Okay, we'll stop that. Go back and then make one final change to get it back to where we had it before. Just get rid of what I had commented out. Save that, save that, save that. And now we're ready to run the debugger one last time. And you can see here that now I'm still, have visibility of that intermediate value. But then when I come in here and look, I'm seeing that, okay, it looks like I'm getting all 4 rows that are on this particular order. So it looks like everything is working correctly. The next thing that we need to talk about here is the SetRecursion function. And what this does is it sets the maximum number of iterations for recursion and loops within an expression because the default is 50,000 loops. That applies to whether it's in a while loop or if it's in a recursive custom function. And so this gives you the ability to expand that if the situation calls for it. You can use it to increase, but you can also use it to decrease because you may get, you don't want it to get stuck in a loop and go forever if you know it only needs to run 100 or 1,000 times. You can drop that number instead of just relying on that default. So it returns a question mark if the maximum is exceeded, and of course that is true also if limit is not changed at all. And then naturally it's going to return the result of the expression if it does not reach that limit. Function looks this way. Your expression is one parameter, and then the maximum number of iterations is the second parameter. So let's go ahead and look at a couple examples of using SetRecursion. And just for simplicity's sake, we're just going to go ahead and run those 2 scripts here from our script workspace. So go ahead and run the first one, and we get the expected question mark results. So what was the calculation that is being run that generates that result? So here's our first example, and this is where you can see here is our parameter of the expression, which is our while calculation, and here's our max iterations, which is set to 5. But as we see here within the while statement itself, is it's supposed to do 10 iterations, and so that's what has caused the question mark to appear. So if I go in to the script itself and then just make the quick change, and we'll set that from 5 to 20, save that, go ahead and run it. And then we get our result rather than the question mark. But what you'll notice down here is that it goes up to 11. That was maybe not the expected behavior, but that's where being very deliberate about your exit condition is very important. Because we're using the less than or equal operator than just the less than, the calculation continues to iterate while that condition is true. So once I is incremented to 10, it is still true, so then it increments to 11. And then that is when it finally exits. So that's just one of those potential gotcha areas, is you want to make sure that your exit condition is set properly to give you the right result, and you don't end up with one too many or one fewer than what you need to get the proper result. All right, so here's our second example, which is another simple script that's going to open up in the dialog box. And again, the default is 50,000. Obviously, the SetRecursion is working correctly because we're getting a result of 100,000. So what does that script look like? And that is what this one here is. Again, here is our expression as parameter number 1. Our maximum is 200,000, but our exit condition is set up to continue looping up to 100,000. Now you'll notice here, I went ahead and highlighted the square brackets in red because this is one of those cases where, because there's a single expression in both the initial variables as well as the looping logic, is that you don't actually need those square brackets. You could just put in the semicolon at the end. Personally, I would argue, again, that you would go ahead and leave in those square brackets just for consistency's sake. Now that might be my CDO condition talking. That is just like OCD, except the letters are in alphabetical order like they're supposed to be. It's just something that I like, and I would encourage you to do the same just for consistency as you go from one simple calculation to one that's more complex. So with that, we can look at our last slide of our time together, and that is as we think about the function variable scope, which is something to keep in mind, especially as you get into the more complex functions where you've got functions that are inside of each other. What we're going to do to help this is we're going to look at a couple examples with a while nested within a let function as well as with a while function. I'm going to refer to them as the inner and outer function as we go through our discussion, so I don't know if that's the proper terminology, but that's what makes sense for me. And if you want to dig into this any more on your own, a lot of what we're going to look at here is based on the example number 3 in the Claris FileMaker Pro help for the while function itself, and you can see that the link right there. All right, so variables that are defined in the outer function can be redefined in the inner function. Of course, they're available to the inner function, but you can change them. And then variables that are either set or reset in the inner function are only available to the outer function if they're returned as part of the result. They just don't automatically inherit that information once you get back to that outer function. And then this last one, which was probably the hardest one that I had, just kind of wrapping my head around, just that, okay, I understand it now as to why it's going to work this way, but it wasn't quite the behavior that I would have expected. And that is that variables that are set in the outer function and updated by the inner loop revert to the original values at the start of each repetition. All right, so let's go ahead and switch contexts one last time here, and I'm just going to go ahead and run the script to generate the results. And this is a while function nested inside of a let function, and there is the output. So let's go ahead and take a look at the calculation that generated that into a text editor, and just done a little bit of color coding so that we can see that, okay, here is our let, and then here is the while that's nested inside of it, and then we come down here to a result of the let that is added on to the result of the while. All right, so what's exactly happening here? Well, we're setting a string, we're setting another local variable to a number, and then we're setting our output, which gives us our line 1.0, which is just the string and the number. As we get down here to our while, you'll see that we're setting our index number. We're going ahead and grabbing the out without changing anything, which sets our line 2.0 over here, which again just repeats what was there. So we're inheriting that information from the let inside the while. And then we're going ahead and changing the value of the string that says that we've now initialized this variable inside that while. And then we're generating the output without changing the number, so that's where we get this initial 1. All right, and then we get into our exit condition, and then now down here to our repeated logic, which the first line is the output 4-point index, again string and number. So we're inheriting the string from the while loop, we're inheriting the number from the let, which gives us initial 1 here. But then we go ahead and change the values to loop, which is the string, and the number is set to 2 now for output line 5. So that's where we get 5.1 now is loop 2. But when we come back here, because we're going to repeat this logic one more time, is that now the out 4.2, the string stays loop because it was set inside here, but because number 1 was actually set here without being changed anywhere else, is that it actually goes ahead and reverts back to number 1, and then 5.2, it's reset again to loop 2. Our result from that loop is the 6.0, which again is the string and the number, which are from the last time it was worked on inside our repeated logic. But then everything reverts when we get back to our final line, because that's not part of the results here. That wasn't passed out, so we go back to the number and string that were defined up here when we get down here to line 7. It's something that I had to stare at quite a bit. Hopefully that gives you enough information to know that you need to be worried about how those things are going to react, so you can go in and dig into it a little bit more on your own. That's the first example. Let's go ahead and take a look at a second example where we've got a while nested inside of another while. So there is the result of the calculation, and let's go ahead and look at that calculation again, in a text editor with a little bit of color coding added. And you can see that it's very similar to what we've done before, where the initial variables, we get our line 1. Again with line 2, because we're inheriting what was set up in the initial variables in this repeated logic, that line 2.1 has the original values, and then we change them and then get down here to our line 3.1, which includes the updated values. Then we come back here, we run through that loop again, and because those values are in that same outer while function is that the 2.2 and 3.2 lines, as you see here, maintain those values. So then we get down here to our nested while, where line 4.0 inherits what was set in our outer function. We changed the values, so 5.0 has those values where we have the initial 2 and the number 2. Get down here now to the repeated logic, so line 6.1 inherits what was set in the initialization of our inner function, and then it is changed when we get to line 7.1. When we come back here to line 6.2, is we actually keep the value of the loop, but the number resets because the number has been set in the function. So we're back to number 2 in loop 2, and we change it again for 7.2 to where it's still loop 2, but now number 3. All right, and then our output, because that was the last thing that was defined here for our number, then we get again loop 2 and number 3 for line 8.0, and then again, because this is the outer function, we go back to those values which were the ones that were last set here by our repeated logic here to get back to loop 1 and number 2. Again, it's certainly a lot to get our minds around, but something you have to be conscious of as you start building more complex functions as to how that variable scope is going to change as you start nesting things. With that, I thank you once again for spending some time today with me as we looked into the while function, and I hope you enjoy the rest of AutoEnter Live. Have a great day.